Welcome back to my channel. We're going to be talking today about Python and Postgres and how to use them together effectively. Really exciting topic, and as usual I brand myself today using Spark Mug, which relates to a book I wrote on Apache Spark I'll talk about in a minute. And of us, I'm also wearing my Python shirt in honor of this topic. I don't have a Postgres shirt yet. Got to get one, maybe a Postgres mug. That would be cool. The emphasis I want to focus on is these two services, these two products, which are both free and open source and have a very powerful development community, are better together. If you're not aware, I wrote a book. I left Microsoft a little over a year ago and spent most of this last year writing a book called Master Azure Databricks. This is a book all about how to use Apache Spark, which is the most popular by far open source big data and analytics platform. The creators of Apache Spark founded a company called Databricks, and Databricks is really a wrapper intended for the cloud around Spark, and it runs on both AWS and Azure. And I got very integrated and familiar with it when I worked at Microsoft. So excited I left to write a book because there was nothing out there that covers Databricks or Spark for that matter. There's no sort of single place where I can kind of learn both together and really cover both Spark and Databricks. It's a comprehensive resource, and it takes you from beginner to expert very methodically, very visual, step by step, hence the title. And you'll learn. It says, this company wants to start with a project and you're assigned, and kind of walks you through. We're in Common San Diego almost, kind of follow through till you get to the end and say, now you've got a machine learning pipeline with all your data analytics and everything going. It covers PySpark and Python coding and SparklyR and SparkR. And I was even able to reach out to some of the rock stars around SparklyR, SparkR, and people who wrote these things, even at Databricks, to say, could you take a look? Am I missing anything? And I got some really good input. Now, it is available on Amazon. You might ask, can I have this as a PDF? No, you cannot. However, there's a free Kindle reader available for any device, so that shouldn't be an obstacle. It could be a phone, it could be anything. And I want to point out something you may not be aware of, but Kindle devices are dirt cheap. I mean, obviously, Amazon wants you to read their books and spend money. This is a 7-inch Kindle online, I just checked. It's like 49 change. So, I mean, it's so dirt cheap. This is a pretty powerful device. I was so excited about how cheap these are. I just started buying them. I have a collection now. I have 3 of these. I have a couple of 8-inch sizes. I've got 2 10-inch Kindles, one so that I can read it downstairs, another one upstairs because it's so cheap. So I just buy Kindles. I kind of collect them. I even have a Kindle Paperwhite because sometimes when I'm reading fiction in particular, I don't really like the glare and the color, but I do like it. Like this one I prefer when I'm reading technical books because sometimes there is some color and contrast I want to see, and it's generally a larger screen. Anyway, go get it. It's worth it. Where are we going in this video? First I want to call your attention to the links, which I will hit up in a minute. But one is getting Postgres itself, because obviously you're not going to get too far without Postgres, or feel free to use a cloud service. All 3 major clouds offer Postgres as a platform as a service. What does that mean? It means you kind of just go click a few buttons and suddenly you have a database sitting in any cloud environment that's ready to connect to and use. That simple. You don't have to worry about administration or anything because that's what PaaS does, platform as a service. Microsoft has one, Amazon has it, and Google Cloud has it. Those are in my mind, the 3 big clouds. Okay, so you can follow the link. And I like to sometimes have a database to start with where I don't have to build it, that I can just play around and query. And if you follow that link there, PostgreSQL tutorial, it actually has a demo database you can install and even a tutorial, which is awesome. We're talking about what is Postgres first, why use it, and a riveting demo. So let me step through here, and I will just quickly click on this just to show you that if you click, you can go here and pick your flavor. I use it on Windows. I have a thing when I talk about I did a consulting contract and I knew nothing. I didn't really know much about Linux. I have used Unix. Knew nothing about Postgres, and I was able to get up to speed within a day and said, sure, I'll take that contract. So that's how powerful it is. It's really easy to pick up if you've worked with other database systems like Oracle and SQL Server. Let me get back to my slides for a minute. Okay. What is Postgres? And by the way, you can say PostgreSQL or Postgres. The reason is originally it was just called Postgres and then it ended at the S. But then SQL support was added many years ago, and then they decided to emphasize that by saying PostgreSQL. I want to say PostgreSQL, but that doesn't sound good. But yeah, what is Postgres? So I'm going to take the easiest form because if you know me, you know I'm lazy. I'll just work night and day to find a better way to be lazy. That's my motto. It is a free and truly open source enterprise database management system. What I mean by that is truly open means unlike MySQL, which many would say kind of got taken over by Oracle when they bought Sun, I believe it was, kind of lost that sort of independence, and now you've got this concern: is Oracle trying to manipulate MySQL users? Could they stop it? So the creators of MySQL then created MariaDB, and now you've got this conflict, and you've got two different paths now of development of separate products. Postgres does not have any of that sort of luggage. It just works. It's been around, and somehow it seems like no company, as far as I can tell, owns Postgres. So there's no fear that somebody's going to buy it and own it. And that's why I think it's getting more freely adopted. It performs really well. I say performant, meaning it can scale and perform well. It supports large databases. And I mean, like anything you can think of that Oracle as SQL Server can support, you can consider Postgres able to support. It has features, and this really surprised me when I started working on Postgres a few years back. Like, wow, it has the ability to connect to other databases and read flat files. It has the ability to create all kinds of indexes, including things like include indexes and things that you don't typically. It can even do partitioning. That's a relatively new addition, but true partitioning, and features you don't find in other databases, which like table inheritance, go figure. But really good stuff. It has resiliency and high availability, and I mean things like load balancing, multiple servers. It has the ability, if you look at Amazon, of scaling out. It has high availability, the idea that you can do failovers. This database goes down, flip on another database. Really important too when you think of licensing, because in many scenarios, if you have that failover, you have to pay MySQL licensing, whatever vendor you're using, because they're going to say, that's another database. Postgres, have at it. It's all free. And it runs on many platforms. And that's another thing I find intriguing, because I think of Oracle as being a Linux, Unix-based database. When I used it, that's what it was. And I still think of SQL Server as a Windows platform database. And I know SQL Server says, you know, we run on Linux and containers. Not exactly native running in my mind, but okay. But let's face it, if you're using Linux or Unix, you're going to be on Oracle. And if you're running Windows, you're probably on SQL Server for a database if you're using a commercial product. Not so with Postgres. I needed it and tried out. And so I downloaded Windows, it installed with binaries, and I'm up and running in minutes. So I was really excited just about that. Now, Amazon is a very, obviously large, successful, high-tech company. And their cloud is by far, has the largest market share. I mean, way ahead of anyone. Now, to say that, and yet they adopted sort of Postgres as their child, if you will, data service that they wanted to integrate heavily, is no small compliment to Postgres and what it does. Redshift, if you've heard of it, is a scale-out platform akin to Microsoft Azure's Azure Data Warehouse, what it had been, now Synapse. I'm a little cautious. Synapse is becoming more of a collection of things, but that scale-out SQL relational database. And they have all three cloud platforms I mentioned have Postgres as a platform as a service database. And I want to emphasize that means you can just go in and you won't pay licensing costs. If you were to go and you say use SQL Server on AWS, there's going to have to be some additional cost just for licensing. And if you install, of course, on a VM, well, yeah, you're going to get full licensing costs. Anyway, these are really great reasons why Postgres is really good. Now, what about Python SQL with Postgres? Let me try that again. Not Python SQL, Postgres and Python. Well, Postgres seems to have been, as I learned Python, I was surprised to see that it seems to be the favorite database, the default database, if you will, of Python, except for, of course, a client database, which is built in called SQLite, which I have videos on. But if you're using an enterprise database, Postgres is the standard. It seems to be everywhere. You'll always find examples. Everyone's talking about Postgres with Python. And again, it's free and you can use it, so it's a great place for data analytics, or if you're doing, like Django or something and building full-blown websites and web apps with it, it's also a really good choice. It is, in fact, the default and set up already to go with Postgres. So it's like instantly you can be doing Django websites with Postgres. Now, there are several ways to use Postgres with Python. Because of this sort of integration and a lot of features, The first is, and I've demoed this, I believe, in another video I did, which is on using the Open Database Connectivity, ODBC. That is the way you would access to something like SQL Server in Python. It is also an option to use that with Postgres. There are also a number of Postgres drivers specific with packages you quickly use, and we're going to see one of those, which is very popular, and how to use it. We're also going to take a look at SQL Alchemy. Now, normally I would not, for data analysis, probably choose SQL Alchemy. SQL Alchemy is a really great ORM, which is Object Relational Mapper kind of database, and ideally suited for something like developing web or mobile apps where you're looking for that OLTP connection from your app to the database. It's really well suited because when you have an object-oriented language or platform, you've written your app to be classes and objects, then it's nice to have a mapper to communicate and allow you to wrap code and functions and objects around the interface to the database. And that's what SQL Alchemy is ideally suited to do. It's a bit of overkill for data analysis, but I'm going to use it in a very simple way to get some simplicity in my code with pandas. And that brings me to pandas. Pandas is my favorite way to try to deal with data whenever possible, because it minimizes a lot of code. It minimizes jumping out of the sort of way I'm approaching the data, the paradigm. I don't have to think I'm going to write SQL here and jump around here. I can do a lot more with less work, and that's key to me. I want to get to solving problems, not writing loads and loads of code that aren't necessarily buying me much. And that's where pandas is my first go-to whenever I'm dealing with data, and then I will back into other places if I must. All right, so integration with pandas simplifies things, and that's going to be the main thrust of this presentation. Now, if you've stayed with me this long, the benefit you're going to get here is I'm showing you the easiest way to use Postgres with your data analysis. There are a lot of different blogs and videos, and honestly, to me, they just do too much work to get to what I want, which is just get me the data, throw it into tables, and let me start querying. Many of them start to, loop around and write SQL insert statements and start inserting from here and putting it there. And it's not really necessary as far as I can see in most cases. In most cases, you don't need it. I'm going to show you some situations like that. All right. Now, there's also something I want to talk about, which is whenever you're using a relational database management system, it is really good to have a graphical interface into the database, okay? Because you're writing code in Python, you're in a notebook, you're in Spider or some IDE, you can't see what's really in the database, and you want to. And you can use a prompt, but I'm not a fan of typing prompts. I don't like typing too much. I want things to just be what's there. I've been spoiled with SQL Server Management Studio, and so I want something like that. And SQLite has a user interface even to go in and look at these things. What about Postgres? Okay, so we can see here I am in pgAdmin, and we've got this database. I mentioned the DV rental. So if you install the DVD rental, we can see all these different tools. Tables are typically under what's called a schema, and under the schema we can see here's our tables. That's a little strange, but in SQL Server a schema would be like DBO. The generic schema, the sort of default in Postgres, is public. Let me see, we have our tables, and I can even do something like right mouse click and say I want to create a script around this. I can say show me the create script for this. I can say view data, show me the first 100 rows, and you can see here I get the rows, etc. I can see what's down there. So it's just a nice visual into the environment. If I'm having trouble, it says that table doesn't exist, this doesn't exist, I can go in and look at it. It's kind of like I got my weather app on my phone and it says it's raining outside, and I look outside and say it's a sunny day. The app is not going to be the best source of truth. The database, in this case, wrapping this over, it's better to look through something like this than trust what Python is telling you. Okay, so we've seen that. We've seen how to get Postgres, and we've seen our pgAdmin. So let's jump in and get to our riveting demo on how to actually use this. Now, wherever you have downloaded the zip file for this and installed it, go into that folder, and a little trick you can do here is just type in cmd, enter, and it opens a DOS prompt for you. That's really weird to think DOS prompt these days, but anyway, it's a Windows prompt. And from here, I'm going to type in Jupyter Lab, because Lab is the sort of new notebook environment, and it gives you a few more features. It's sort of 2.0 of Jupyter. It's really cool. And now that I get in here, I'm going to open the folder up, and you can see that you should have this Python Postgres notebook. Open that up, and you can kind of just close this. So let's start walking through what we have here. Okay. So first thing to note is obviously my disclaimer. If you use any of this code, make sure it fits your needs, make sure it meets your requirements, that kind of thing. I don't want you to use something and say, I didn't know it did this. Make sure you always read and evaluate any code you're going to use. Now, if you have not, my recommendation, I have a video on Anaconda. Anaconda is a data science, data engineering to some extent, install distribution for Python. I highly recommend you get that because it will give you Jupyter Lab, it will give you a number of IDEs, and it gives you just about every library you could ever want to work with data analysis, including the libraries we're going to use here. But if you don't have it, you can use pip, the package manager for Python, and install it. We're going to need this driver package called scopg2. Not really sure the best way to say that library name, but that's what you're going to do. Or you could do a Conda install if you do have Conda or Anaconda installed. Conda is sort of a package manager when you have Anaconda. I have it installed, so I'm not going to go through installing that again. And what I want to do now is I'm going to import that package, scopg2, and then I'm going to connect to it. Now I'm going to show you a way to do something which is a little unusual. I'm going to connect, and I'm not going to give it the database because I'm going to use the Python code to create my database, just to kind of demonstrate we can actually do that. So here I'm going to run this cell, and then I'm going to run the cell below it. And I do want to call attention to a little bit of this. I've got this pgcon cursor. So let me review this a little bit first. A very common paradigm, pretty consistently when you're using databases, even SQLite from Python and most really interfaces, is the idea that first you establish a connection to the database. So typically in Python you call it con or something like that. That's my connection object. Sometimes you also create a sort of segue or a way to send messages, if you will, to the database, and that's a cursor. Not to be confused with, SQL Server, you kind of think of a cursor as just a way to step through rows in a table or some query, but the cursor is really more like, think of the path we started with. We're in C:\\/ it's kind of the database connection, but the statements we get, the shell, is actually the cursor. In many cases, we're going to pass statements through the cursor. I hope that's helpful. It's a little confusing, but we create the cursor. All right. Now, once we have the cursor, we're going to go through here. Now, I'm going to do something strange down here. I'm going to actually drop and recreate the database to demonstrate that I can do everything within Python. However, I was running into bugs, and so you benefit from my failings and problems. I put a link here you can reference. But they said the problem is it wasn't letting me do it. It was saying that you couldn't make the changes you wanted. It needed to change the isolation level. What I need to do is add something called auto commit. So I'm going to add that now. It's making this setting, and I'm bringing in yet another library. All right. And now I'm going to do pgcursor.execute, drop database if exists. So I'm going to drop the database in case it's out there, and I'm going to recreate it. So this is connecting to my Postgres instance. Now let me kind of rehearse this a bit. We've got a host here, and the host is localhost, meaning it's my default instance. If I've only installed Postgres once with one server, that is the default name, and I don't have to do anything more. The user Postgres is the default admin for the install, and typically there's a password to go with it, and I use the highly secure password of Brian. It is not a good practice in notebooks or anywhere else to put passwords. So this is a demo. Do not do this at home. Postgres is unfortunately by default not a Windows environment, as I mentioned, and so it doesn't support Windows authentication without some additional gyrations. It can be done though. So this is another really good reason why you're better off, if you are worried at all about your data, to use a PaaS service in one of the clouds, and they're pretty cheap. Then you can use security features like something like Azure Key Vault or something similar in AWS, where you can make sure your password is never displayed and you can use something to get it out. There is also a PG Encrypt, I think it's called, which will encrypt passwords and allow you to sort of put them somewhere and bring them in. Not gotten into that yet, but just so you be aware, this is not a good practice. Okay, let's continue. So let's see if I can run, make sure I ran this statement, run this, and ideally this will create my databases for me. I have learned, by the way, that once you start querying and doing things with Postgres databases, it doesn't want to let them go. It sees attachments, any kind of attachment, even within pgAdmin. If you've got some window open that was looking at something in your database, it will not let you drop it. Now I'm kind of done for the time being with my PG connection object, and I'll explain why in a minute. Okay, first I want to connect directly now to the new database I've created. So that's the biggest reason. Let me go over this. Notice I don't have a database specific because I'm going to create it. So I connect to the instance. But down here, I've got a database. Now I'm naming it AW as an abbreviation of AdventureWorks because my data is really extracts from Microsoft's dummy demo database, AdventureWorks. Let me run that. Now, as I've mentioned many times in my videos, I like to take the laziest way possible because the laziest is also the most efficient. Why waste time? Why write more code than you have to? It's more stuff to maintain. And as a result, I found that pandas is, generally speaking, the best way to handle data in 99% of the situations, and I'm going to use it. So I'm going to import pandas, standard import PD, and then using that tag PD, right, or whatever you call alias, I'm going to use read CSV to bring my data in from CSV files. I could bring them in from anywhere. I could use ODBC and go after SQL Server. Got a video on that. I've demonstrated those kind of things. But I'm going to use read CSV, and I'm not going to give it an index column. And then I'll use this display just to show you a couple of rows. Head 2 is just going to say, give me the first 2 rows to look at. And you can see, you know, it's basic customer information. Now, here's the thing. This is actually copied from online. You can see this link. When I tried to use pandas to SQL, which works beautifully with SQLite, I can take any data frame and just say save it into SQLite, and it does it with no problem. Takes a data frame and turns it into a table, columns, types, all for me, no work at all. Does not work when I use the scicop pg2 driver. Instead, I have to go through that SQL Alchemy. And if you follow this link here, it actually tells you that pandas SQL is designed to support SQL Alchemy and uses that API to support whatever databases SQL Alchemy supports. So it should work with MySQL and SQL Server, etc. as well, as long as you use this. So I'm going to, if you don't have it, again, you should have this if you've got Anaconda, but if you don't, you can do pip install or conda install as shown here. Now, I don't know if this is as visible as I like. Let me push that up a bit. All right, so now what we're going to do is we're going to say from SQL Alchemy, we're going to import create engine. Not a huge fan of the name because as far as I can tell, this is no different than just get connection, all right? But they call it create engine and slightly different format, but what I'm doing is I'm passing in the driver, okay, PostgreSQL, the scicop G2, the path. Now the path is interesting. This is the user ID. That's the password. And then I'm going to say at, and this is going to be the name of the server. And then here's the database. Kind of weird. Kind of looks like a file path. But anyway, that's how you get to it. And you're going to return that result, that pointer to this variable object called engine. Could be anything you want. I'm calling it engine. Mostly because the examples you see everywhere call it engine. And after all, it is using a create engine function. So here we are. Now we're getting to the exciting part. At this point, we have created the cusdf, right, data frame, and we want to take this and we want to persist it. We want to save it to our Postgres database as table customer. We're going to use our engine, which is our database connection object, right? That's how pandas is going to find the database and connect in. And we're going to say here, if it finds the database, if it exists, just replace it, just blow it away and recreate it. Now we can say, somewhere in here I have notes, but you could say append, which is good because suppose it already existed and your real goal is to just add more rows to it. Then you would just say if exists depend, and it would take that data frame and add new rows. The other thing you can do is say, well, this shouldn't exist. I want to fail. So you could also say fail, and it will just abort and say, no, we won't do this. Now I'm not going to have an index in this particular data frame, so I'm just going to say no. I'm going to run it, and not much to see, but it should have written it to the database. So let me go into my Postgres side of things, and let me refresh, and hopefully it worked. And there we are. We have a new database. Yay! And we can look under our schema, and when we go under it, we'll also find there's our table. All right, and we can see the columns. So again, you can see how this can be really useful, just being able to say, did it do it? Is it there? That kind of stuff, because we may get issues. So I love to bounce back between these things. All right, let me go back to my demo here. So we've done that. Now I'm going to do the same thing, and I'm just going to kind of simplify. I'm going to create a product table from the dim product table. Same kind of thing, nothing up my sleeve, nothing new. And now I should have two more tables here. So let me refresh. And there we are. We can say yay. You can see them here. All right, let's go back. Now we have my tables. That's great. There is one implicit assumption in the method I've used, which I like to skip over because it creates a mess, right? But the thing is, what happens if the data frame, there's too much data? Imagine you've got a SQL Server table, which is not unheard of, or Postgres table, not unheard of, with 1 billion rows. And it's going to take a terabyte of memory to fit. A little bit of a problem. Data frames reside in memory, right? They're just all in memory. And so we're going to have a problem if it's a really big table. In most tables, it's going to be fine, but when you get into really large ones, it's a bit of an issue. There's a technique we can get around this by. Now, this is one of these examples where I saw a lot of complicated solutions, and I wasn't happy because a lot of them involved like writing some sort of query over here and then looping over and doing insert statements, which is tedious. And insert statements with SQL can be error prone. It's very easy to get a character off and mess something up. I don't want to do something that's difficult. So instead I'm going to use a really cool technique, and here's some links. I stole this idea. So I am borrowing, so take a look, follow these. Kudos. I even put this person's name, Itamar, can't really say Turner, Traring, but really good blog that explains this. So I modified it to demonstrate to you, but take a look at it, really good. What I'm going to do instead is there's a feature, which you may never have used, with the read CSV, and for that matter, most of the read stuff you can do, like reading from a database as well, called chunking. Chunking is where you say, okay, I want you to get data, but I don't want you to get all the data. Get X rows. So here we're saying chunk size, a chunk is going to be 2,000 rows. Now there might be 1 million rows, 10 million rows, but it's only going to give me 2,000 at a time. It's very similar to a transaction block, if you will. We're going to get a block of this. And nice thing is, it will return it because I'm doing this for loop. It's going to return each 2,000 chunk into my aptly named variable called chunk. And I'm going to just take that. Now what is chunk? It's a data frame, but it's a data frame with only 2,000 rows. And I can now say chunk to SQL, go to sales, engine, and of course I don't want to say replace, or it would just keep deleting each one and I'd only end up with the last chunk that was inserted. So I'm going to say append. Nice thing about append is if the table's empty, that's fine. It will just start inserting the rows. So you can use append even if there is no table, it needs to create it. So this will take potentially a minute. And the trick I want to insert here is sometimes when I'm waiting for something in Python, I'll do something like this. And I do that so that I know when it's finished. It's a little trick. So I know it hasn't finished because I just ran a cell that says print OK. So I'm going to wait, and there it is. So that's, sometimes I don't know. I probably should do something a little fancier with like a prompt box, but there you are, my little cheat. All right, now that that's done, let me find out how many rows are in that table. I created this table, sales. I'm going to go against Postgres and get a count. It is a fairly large table, 60,398. I've actually been able to do that entire thing in a data frame, but it's good to know. So now we can, of course, go over, and I'll kind of do this again, refresh. And if I go to tables, we'll see that we have a sales table. And by the way, there's quite a few columns in here, so a lot going on there. Let me go back here. All right, we're getting there. We're not quite done. I have a lot more things I want to show you, which is riveting. Another thing I want to show you though is in system level databases, a standard in SQL that was implemented some time back, I don't know when to be honest, but they added a schema called information underscore schema. The idea is, now this is a SQL standard, right? So it is supposed to be a set of tables and views that display the objects within the database. What do I mean? In other words, it's called the database catalog, and that concept has existed since DB2 and SQLDS, the original SQL databases. The idea is you have catalogs and you can query, like there are tables within your database that tell you about database tables, and this is called metadata. And so we want to be able to query metadata because I can't half the time remember what the column names are, let alone table names. So this is a way I can go back and say, oh yeah, what are these things called? What are they stored like? So it's a very useful thing, and I'm going to use the read SQL of pandas to query it. Now, fortunately, Postgres follows the standard pretty well, which is information underscore schema.columns. SQL Server follows it as well. We're going to see SQLite, it follows it, but not according to the standard. And so there's a table here that tells our columns, and we filter on table name. There's also a table for tables. There's tables for indexes, etc. So this is really handy. I'm going to pass in the engine, and I'm only going to display a few rows because I want to just give you the idea. And you can see here now I'm getting, these are the column names in that table. Now I'm going to create another connection, but this time I'm creating a SQL Alchemy connection called PG connection. And I need that because I need to do a connect to that engine. This is kind of like a cursor, because what I want to do is I want to add an index, okay, to the table I created. So I'm adding an index to the sales table on order date. It's really a critical concept in relational databases that they support indexes, because indexes allow you to go directly to something. It's kind of like in a book, you go to the index and you say, where is this thing I'm looking for? And it says, oh, that's on page 58, and you just jump to that page, versus reading through every page of the book, which is what you would have to do without it, right? If you don't have this. So if you're dealing with a big CSV file and you ask for a certain date, you know it's going to read through every row to find what you're looking for. And in a large table, this can be a big problem. It's called a table scan. And we avoid a table scan by creating indexes, and indexes allow it to get to quickly. So what I'm going to do is create an index, and I use if not exist just in case I rerun this code and I don't want an error from it. And I'm going to create an index on order date. So I'm going to run that. Now I can't use the SQL query because I was getting errors. Why? Because this expects to get data frame back and it doesn't return a data frame. Okay, now that I've done that index, I want to start building out towards a kind of complex query to show you the power here. A really good idea that I want to give you, and even if you took nothing else away, if all you learned was this, then you got something worth this time. And that is the idea of using a date dimension. What's a date dimension? It's a very simple idea that solved a lot of problems for writing queries. A date dimension, I'm going to clean that up a little bit. A date dimension is when you want to do things on querying related to dates. This has been around since the beginning of queries, right? Somebody wants to see, well, I want you to give me a query for the last 2 years. I want to get a summary of sales by year, by quarter. Sometimes you may want it to say by year, by quarter, and I want you to show me the days of the week that have had the highest sales and things like that. What typically has happened, and I've seen this in many places, is there's this, take the date, parse it out, pull the date, get the year, summarize by that, and create another column, and then get the month. Oh, okay. And then create some sort of temporary table and say, okay, if it's the months here to here, then that's quarter 1, quarter 2. It's a lot of extra code and a lot of extra work. There's a very simple answer. Create a lookup table, create a reference table, should be dimension, and that's called a date dimension. And there's lots of places online you can get free date dimensions or scripts that will write a date dimension for you. So let's kind of walk through this, and I think you'll get the idea. I'm going to just query the date dimension to show you what columns we have in it. So we have in this date dimension the month number of year. So if I join to this on the date key, and the date key is a full date, January 1st, 19, whatever, the 2000 something, whatever, right? And it will have the month number of a year. It'll also have the quarter, right, which is not a natural part of a date. And I could have semester. I can also have fiscal year and quarters, etc., versus calendar. So again, one table can solve a lot of problems. So let's see how this works. Now my real goal is to demonstrate Postgres, but I want to show you a little bit more here. So what I'm going to do is run a query, and I'm going to be using my sales table. I'm going to join the date table in, dim date, and I'm using the order key and the date key. I'm going to roll back for a minute because you may have noticed something. Why do I have quotes around my column names? Kind of weird. Quotes are similar to what SQL Server does. They put brackets around things. When you have spaces, when you use anything that it will essentially break, not understand, you can kind of put something around it. Postgres is case sensitive, and if you use uppercase, then you're going to have to put quotes every time you reference the column. I recommend, I'm lazy, I would use lowercase. You can use underscores if you want to break up words, but camel case and things, which I actually worked on a contract and they did that everywhere. And honestly, it really gets to be tedious to always have to make sure you have a quote. And you always have to remember, well, is there a quote? Because if you do this, mind you, you have to remember that this is always capital Y. And if somebody in one case made that a lowercase, it won't give you the answer until you get it right. If you make a standard of just say stick with lowercase, it's going to be a lot easier. At least that's my preference. But I was even lazier because I should have done that change, but I wanted to show this. That's the answer. Anyway, I wanted to show you this because that's kind of key. The CSV file was brought in and it had this column headings at the top, and I used them, but it's kind of given me this experience. Now I can use SQL to put a view over it, which is not a bad idea. Bring it in and it's horrible, but then add a view over it. Good practice anyway to use views instead of base tables. Back to our story though, date key. Now I'm going to say, okay, order where the date is between. Now I want to really highlight that. I'm only filtering a subset of dates. This is where the index is really going to pay off. Imagine I have 20 years of data here. This was something on a contract I did, was a key thing. I mean, they had like 15 years of sales data, and they only often needed slices. They didn't have good indexes. Ideally, in a case like that, you want what's called a clustered index. More on that later. But basically, you want indexes because it can speed up the selection of data. Now, the dim date is helping me because I can say group by calendar year and quarter. I don't notice I'm pulling those out, no problem. And I just join to the date table and I'm good to go. I don't have to parse. I don't have to do this laborious thing. Don't tell your boss. Pretend you really worked all day doing this. You know, sweat on your brow. You get credit. It could be a promotion. But it's really something many people don't still realize. It's a simple solution. So that's kind of a neat thing here. And what we're going to do is create a query that's going to give me a summary by year, calendar quarter, and it's using dim date. Now you might say, well, isn't there a lot of overhead joining on the date column? Well, for one thing, dim date should be indexed by its primary key, right? So that's typically a sorted index, clustered index, so it's fast. And think about it. How many dates are you really going to have? If you have a year and you have for every day, that's 365 rows. So even in 10 years, you only have 10 times 365. Not a problem for an enterprise database. It wouldn't even be a problem for SQLite, which is client-based. So let's go. Let's run this. And here we go. So we have a nice summary. Now I put this little round function in because it kept coming up with weird exponential notation, if I remember right. And you can get rid of that, or decimal places. So round will get rid of that. And we have a nice little summary here that's suitable for framing. So that's one thing I want to show you. Now I want to give a little bit more. I want to point out things like leverage the features you have in SQL, something that most demos don't do, some do, but Python is really good for reusability. Here's an example where, if you've noticed, I forget column names a lot. And what I want to do is I need a quick and easy way to get a list of columns on any table. So rather than pasting this query and changing it everywhere I want, I'm going to create a little function. Now I'm going to bring pandas in just to make sure it has the function I'm going to be using here, right, PD, and I'm going to define a function called getColumns, and it's going to take the table name as a parameter. And I'm just going to attach this format, which will replace my symbolic parameter here in the query, and voila, I have a function that will give me column names back anytime I want, and there it goes. My point here is leverage Python. I'm in a notebook, but that doesn't mean I can't create classes and functions and things, or even have something as a script externally externally and just run it and use it. And I've done that in other presentations. So that's kind of handy because now I can just use that whenever I want. Okay, final stage of our riveting demo. I'm trying to conceptualize another stage in how you might use things. Postgres is typically, as I mentioned, it's an enterprise database along the lines of, say, Oracle. And that's great. One use case in data analysis is you can use that as your repository, a place to get clean, good data, collaborate with many people on a team. Free, right? Great. And it's secure, and you put it behind your firewall and you lock it down and people have roles and da-da-da. Okay, great. But there's also a use case where you say, well, I want to do, my own thing. I want to be able to drop tables, play around. In fact, if you're me, you're always worried about you're going to drop something people need and people will not like you. And it's always a problem in databases. DBAs do that sometimes. They have to be very careful. They have a lot of power. So a really good idea is that's a good use case. But another good use case, if you don't want to go through the work and things of keeping Postgres, sometimes it's better to use SQLite. And I have a whole bunch of things, as I mentioned, on that. This is better for when you just have less scalable needs, but still good. You can have, up to terabytes really with SQLite. But the biggest thing is, one, I may want to share it, really share it. In other words, I want to just create an extract. SQLite, it's a file, right? And I'm going to see that. And I can just email it to somebody. Not good for security, but it's good for things like that. It's also good because I can play around, I can drop, I can slice. It even has an in-memory capacity where if I don't want a table, I can just push it all into memory and be working there, so for performance. So Postgres is something that can be seen as sort of a platform to operate from, and SQLite can be seen as a very useful tool to work with the data in real time, if you will, and maybe not even keep what you're doing around. All right, so we're going to have to import SQLite functions we got there. And now we're going to do SQLite 3 connect. We're going to return this object to SLConnect, SLCon, right? And here's the database name, aw.db. SQLite's real riveting. It's really complex. Now notice when we do Postgres or other databases that are enterprise, you never talk about files. That's hidden underneath the covers. SQLite is more like Microsoft Access. It's got a file and you open it and you use things. In this case, if this file doesn't exist, it will create it. And if it does exist, it says, okay, open it up, connect with it, and open up and get the things in there. So let's run this. In this case, I don't think it does exist. And if you print the connection, it just says, yeah, I'm a connection. Now what I want to do is I'm going to create a cursor. And this cursor, again, is sort of that entry point because certain things I want to do will require a cursor. So I can do that. And again, I keep forgetting what's in sales. So there I am, my handy little dandy function, and I can look for what columns are in here. And based on that, out of all that, all I really wanted was sales amount. So probably didn't need that list. But interestingly, what I want to do here is now create a query where I'm going to join to customer. Okay. The idea is I want to extract data from my Postgres database. And admittedly, if I used ODBC, I could be doing it from SQL Server or something. But I want to pull data out of my Postgres database and persist it into SQLite. My goal here is to show you kind of how to share the services and blend them in a way that optimizes your productivity. That sounded pretty impressive, didn't it? All right, anyway, so what we're going to do here is we're going to join sales to customer, and we're going to do this on their keys, which is the customer key is the column name in sales, which gets me to the customer here. So that's what relates my sales to the customer who bought the product. Now, I'm using these aliases because I'm too lazy to keep typing out customer. So what I got here is now I can just say C, and so this I also identify as like, where is this coming from? I like to use aliases even when the column names are unique because that can change and I don't like code breaking. And I'm also demonstrating like how could I get around the Postgres problem with always having to quote. And the way to do that is simply use this as feature. Now in this case, I'm merely preparing this query so that I can persist it to SQLite where it's not as much of an issue. But just to show you that if I did something like this and were to create a view on top of my base Postgres table, then the view doesn't require me to refer to that quote anymore. Here I can just use the created names, and we'll kind of see that later. And in Postgres, I had to look this up, I have to admit. I want to say like, okay, I know in SQL Server how I would calculate something like the actual age of a person, and birth date is a column I have. How do I calculate age in Postgres? So in Postgres, there's a date part function, and this is something I stole off the internet. I don't remember where. I apologize for that. but I can do this subtraction and get the person's age, which is pretty cool. So I got this nice little table that maybe I want to slice and dice. I'm not summarizing it because I want this to be something I can query. And again, use your imagination. I could be joining to a bunch of other tables. I could, once I'm in SQLite, I can join to other things with it and really step up my analysis. And mind you, SQLite also supports indexes and things, so I can get better performance and speed, all that stuff. Now I'm only creating a variable to hold this query before I go through and use it, because it makes it a little more readable in this case. So I'm going to just demonstrate. I'm going to run this query, but only display a couple of statements, a couple of rows. There it is. This time I'm going to run the same thing without the head statement. And what I'm doing here is saying read SQL, but what am I doing? I'm returning the results to a data frame. So let's look at this carefully. I'm going to be running that query, and I want to sort of show this, the engine, right? So I'm running it, and I've got the engine, and the engine is pointing me to Postgres. So I'm running this query against my Postgres tables, and I'm going to create a data frame. That's what we need to understand in this statement. Great. Now what I want to do is, as I've seen before, I need to back up a minute. I've got a data frame, has data from Postgres, okay? Now what I want to do is take that data in the data frame and save it as a table to SQLite. So I'm kind of using it. I'm saying grab it from here, push it here. Now I love this approach because look how easy it is to do, right? I mean, one statement. This is all it took. And I now have a data frame. And that's the key to pandas. Always get a data frame, and pandas let you do almost anything with a data frame once you have it, which I love. So now with my data frame, I'm going to say to SQL, I'm going to create a table called sales data as opposed to sales. And you can tell here it's going to the SQLite because I'm using the SLCon at SQLite connection, no index. And I'm saying if it exists already, just replace it. So it will delete and replace. Small point, I have not invoked SQL Alchemy because SQLite is so easy to use with Python and pandas. It's ubiquitous, so it's just great. That's another reason why you may choose to bring things out of Postgres sometimes and use it locally, because it just integrates beautifully with Python. Okay. It also, by the way, will offload compute to your machine. So if you want to not tax the backend server, good use to do it also. If you have a really large table in Postgres, a good idea is filter out the subset you need, bring it into SQLite, and bang away against it, and the DBAs will love you. The company will love you for not burdening the database with heavy queries. All right. So what I'm going to do here is I just demoed a little bit of SQLite. I have a lot of things I want to post in my description, but take a look at my other videos because one's all about Python and SQLite. What you can do is, while I mentioned SQLite does not implement the data catalog in the information schema approach, they have this command called pragma, and you can use table info and get information, in this case like about sales data. So I'm going to run that, and this just tells me, oh, okay, here's my new table, here's the columns and the SQLite data types. All right. Now this would probably be a good point to point out that, as I mentioned, I do not like to work with databases without some window into them. And so you can see here, and I do talk about in my video, I have a whole video I think about this one, SQLite Studio. I'm going to open it. And I'm not going to bother getting to this, but basically all I have to do is go here and say open the database, add a database to it, and you can find your database. And when you do, actually it does show it. This is, I think I opened this earlier and it's still pointing. So you can see that you can query, you can slice and dice. You have similar functionality to what you have in pgAdmin. It's a little bit lighter in functionality, but really useful. Honestly, I love using SQLite Studio or SQLite. I mean, I'm like, wow, this is just great to have that. All right, so now I'm going to query the data that I have transported all the way from Postgres to my SQLite database. And there it is. And here I'm just looking and saying, okay, selecting data from sales data. I'm only asking for 4 rows, and I'm using the round statement. Again, because it doesn't display numbers real well there. Now, I'm going to do a little aggregation because we love to do aggregation. Aggregation means we're going to summarize in some way. We're going to summarize the sales amount by summing it up, total sales. We're going to do that by grouping it on education. So group by the education level, because again, in a very small way, but this could be something we might use as a model feature. We want to predict what product a person's likely to buy. Well, education level may affect that. Salary is probably going to be a big one too, right? But people who are more better educated may favor certain features, may favor certain things that over other ones. So, and there may be, a sort of connection between features like salary and education, which you have to be careful in model training, but this could be a feature. And so I'm exploring, right? EDA, exploratory data analysis. So I'm selecting education. Now here's a weird thing in SQLite. When I wanted to format the sum amount so that I could get commas, I had to use a printf function, which is very C-like looking, but hey, it does the job and it gives you a lot of flexibility, so I can't complain about it. And then I'm just going to run this, and again, this is SQLite because SLCon, and I'm saying index column equal education because it kind of gets rid of that annoying sequence number on the left and it formats it kind of nice. And now we can see here's my education, here's my summary, no decimal at all, just integer. So all in all, looks pretty good. So please extrapolate into various ways you would use this. Use your imagination. The sky's the limit. But there's a lot of power here, and I'm actually building a series of videos to kind of do concentric circles, if you will, like a tree, so I can show you all the different ways you can use these tools to jumpstart, really accelerate your productivity and make life easier. That's the goal. Now, one of the things you want to do when you're done is close your connections. So here's my PG connection. SQL Alchemy uses the engine variable. We dispose of that to get rid of it, and then we get rid of the SQLite connection. We want to do that, otherwise it leaves connections open, and particularly when you're talking about things like Postgres, it adds a lot of overhead if you've got a lot of connections open. It's a very bad idea to leave things open. Typically with databases, you want to get what you want and get out. I didn't show it here, but typically I have a function I've demonstrated in another video I did, which goes against a SQL server, grabs what it wants, throws it into a data frame, closes a connection, and I just work with the data frame, which is a really more efficient way to work. But again, if it's like a billion rows, not going to work. We talked about what is Postgres, and we learned that it's an awesome, open source, very liberal licensing model, enterprise database that we can get and do what we want with it, and it's great, and it's very powerful, and it is, if you have any doubts that this can compete with the big leagues, I hope I dispelled them. Take a look, explore it. As I mentioned, I did some consulting on it, and I was very kind of prejudiced against Postgres going into it, like this isn't as good as SQL Server. And I was, admittedly, SQL Server does have features that I do like a lot about it, especially around BI. But I had to admit it was impressive in performance and in the price. So yeah, you got to look at that. But why Postgres with Python? Why am I talking about Python and Postgres? Because they work really well together. They're both free, they're both open source, they both have the same philosophy, and there just seems to be this really amazingly natural synergy between these two products, if you will, open source software products. So, and I've shown you, Python just has this really great tendency to kind of keep iterating over things until they simplify to the point where you get to a single statement, what used to take a page. And pandas with Postgres, once you get through the layers and you kind of realize, like I had to figure out SQL Alchemy as a piece there, it's just a great synergy. And as I mentioned, I try to use pandas everywhere as much as possible and only go to other things when I can't do it with pandas. So I did a riveting demo. I hope you liked it. And kind of a side demo I hope I've shown enough of is, of course, downloading and getting the tools, but also making sure you have a visual GUI to look into and test your queries and see what's going on in the database, because again, it's kind of like the weather. I mean, do you really want to be looking at your phone when you can just look out the window? And that's kind of what the GUI does. It gives you direct access to see into the database. So I want to thank you. I've gotten a lot of great comments. Please add more comments. Tell me what you like, tell me what you're interested in, share with your friends. Like to get the word out. It feels great to know people are getting a lot of value out of this. I feel a great deal of satisfaction from that, and that's why I keep going. So thank you, and yeah, have a great year.